A couple of weeks ago, Apple introduced the first generation of Macs powered by the M1 CPU. Reviewers praised the new MacBook Air, MacBook Pro and Mac Mini as nothing less than revolutionary, beating comparable Intel machines both in terms of computing performance and power consumption. On a personal level, this prompted me to sell my 10-core iMac Pro and replace it with a MacBook Air hooked up to a 6K display. And I'm happy to report that it performs flawlessly in the legacy Microsoft Office apps and in 4K video editing with Final Cut Pro. But this video is not about Apple. It is about how Apple is directly influencing Tesla and indirectly the entire automotive industry. Let's get started. Any car you buy today has tons of electronic components. For example, the head unit. This is where all the information that you can see on your car's display is processed and prepared. You can think of it as kind of a desktop PC. When a traditional car maker goes out to source a head unit, they would solely rely on off-the-shelf components, and they would look for one supplier to take care of everything. Let's contrast this to how Apple is operating. On the vertical axis, Apple has always controlled the system design and the supply chain. Apple designs the motherboard and selects the ICs and then orchestrates an entire ecosystem of suppliers to deliver the product. And by the way, a lot of PC makers are working like this as well. Where Apple is really different from the rest of the high-tech industry is silicon design. While other makers of smartphones rely on agnostic silicon from Qualcomm, Apple introduced the first custom system on a chip with the A4 that launched with the first generation iPad 10 years ago. This enabled them to tightly integrate software and hardware and offer a unique user experience. And as a result, we are now in a situation where Apple reaps about 80% of the total profit of the entire smartphone industry with a market share of just 12%. And it appears that Apple is about to repeat this trick with the M-series CPUs for Macs. And it doesn't stop there. About 5 years ago, Tesla hired part of the team that is developing silicon at Apple. And this team is now developing custom silicon for Tesla. With this, Tesla is aiming to dominate the automotive industry in a similar way as Apple is dominating the smartphone industry. And this domination is based on three pillars: cost, latency, and power consumption. Let's look at these more in detail. People refer to Tesla cars as servers on wheels. And what you see here are the key components of the server. You have the autopilot board. This is the most critical component. It processes all the information coming in from radar, cameras, and ultrasound sensors, and steers, accelerates, and brakes the car. The infotainment board and the infotainment processor board are similar to the head unit in traditional cars. And the RF communication board ensures connection to the internet. The only component where Tesla acts like a traditional car maker and buys off the shelf and acts in a one-stop shopping mindset is the totally uncritical infotainment processor board that is supplied by Intel. For all other components, Tesla acts like a PC maker. They design the motherboard, and if you squint, you can even see the Tesla logo on the PCBs. And they control all the parts on the motherboard and manage a pyramid of suppliers. In terms of silicon, Tesla relies on agnostic silicon from NXP for the infotainment board and from Intel for the RF communication board. But for the mission-critical autopilot board, they design their own custom silicon. And they do it for three reasons: cost, latency, and power consumption. Let's start with cost. Here on the left, you see the hardware 2.5 that is in my 2019 Model 3. Zoomed out, there are 4 chips, 3 from NVIDIA and 1 from Infineon. The total BOM cost of hardware 2.5 is $280. On the right, you see hardware 3.0. That is in the new Model 3 and in the Model Y. The job originally done by the 4 chips from NVIDIA and Infineon is now performed by 2 Tesla chips. These Tesla chips are not only far superior in performance but also cheaper. With the switch to hardware 3.0, Tesla is saving about $90 per car. And in the automotive industry, $90 per car is huge. Let's now look at the other two advantages Tesla is seeking: latency and power consumption. Latency is the time the system needs to react. In general, the expectation for an autonomous driving system is to react in less than 100 milliseconds. And that is faster than a human under ideal conditions. But you see that custom silicon is even faster. An FGPA, a field programmable gate array, is mostly used in system development, so not really applicable for series production. And this leaves ASICs, application-specific integrated circuits. These are faster because, as the name suggests, they only contain the functions required for the specific application. We see this even more pronounced in the power consumption. All the overhead of the functions in agnostic silicon, like CPUs and GPUs, requires a lot of power. And this can easily cost you 1 or 2 kilowatt, which may translate into loss of 10% of driving range. In this dimension, a custom ASIC like the one used by Tesla really shows its strength. It only uses a fraction of the power of all other alternatives. So by using custom silicon, Tesla achieves excellent latency in autonomous driving without sacrificing precious driving range while saving money. It will be very interesting to observe traditional car makers reacting to this. They have two directions in which to move. The vertical direction gets car makers more in the mode PC makers have been working in for decades. Rather than delegating everything to one supplier, they would take ownership for the system design and specifically for the motherboard. And they would select most of the ICs on the motherboards and the vendors of these ICs. I think that it is pretty certain to see car makers making this vertical move. The horizontal move to the right is an entirely different story. Personally, I believe it is needed if you want to compete in electric vehicles. In the end, you can only differentiate in 4 areas: driving range, autonomous driving, telematics, and augmented reality. Competing successfully with off-the-shelf agnostic silicon appears like a risky proposition to me. And the many makers of Android smartphones that struggle to differentiate against the iPhone are a cautionary tale. At the same time, investing in custom silicon and adjusting the entire technology stack is a tall order for a car maker. Regardless of the outcome, procurement will play a much bigger role in shaping the technology roadmap at car makers in the future. Anyway, I hope this was a good explainer for what is going on in the automotive industry and how Apple via Tesla is shaping things. If you have made it this far in this video, you must really be into these topics. Should you want me to dive deeper into specific aspects of this, let me know in the comments down below. And as always, I promise to get back to you within 24 hours. And if useful, I may even respond with a dedicated video. Thank you for watching. Please subscribe and I see you in the next one. Bye.